I'll come by and pick them up right away. That sounded like a TI-84. Oh, triangles, yeah. A bit more triangle stuff before we jump in, and I'll do some examples from the booklet, like the homework. Some have asked to go over that. I will. I just need you to first and foremost, always try that. This unit is probably where that's saying the only way to learn is to do it. This is really, I'm going to emphasize it on this unit. Like when I assign, you might think, oh, you know, it looks so easy when Mr. Dirksen does it. I got it. I totally, I agree with Mr. Dirksen. That's how it should be done. That's not going to be good enough, okay? So just to make sure we all have background knowledge, right? We have our three main types of triangles: scalene, isosceles, equilateral. Scalene, all sides are different. And if all sides are different, what do we know about all angles? They're all different. Some of you might say, yeah, I know that, but it's very important for you to actually remember that. All angles are different. Okay? Oh, you're going to think all angles are parallel. And different. Let's just go ahead and write that in. All angles, all sides are different. So that's very basic, right? Also, what I'm going to add here is longest side. This is going to come back for trig. Is going to be across largest angle. So longest side is always going to be across the largest angle, guaranteed. And it goes without saying that the shortest side is going to be across the smallest angle, right? So I'm not going to write that down, but this is just something to make sure you remember. Isosceles, two sides are congruent. Two angles are congruent. And not just any two angles. It's the two angles that are across those two sides that are equal, right? Remember that. And so, for instance, if you have a triangle ABC, if these two sides are congruent, then which two angles are going to be congruent out of A, B, and C? B and C? Yeah, it's going to be B and C because watch. This side is across B, right? Sorry, this. And this side is across C. So it's these two angles that are going to be congruent. Okay. Also, if one angle is given, you can find the other two. And I'm going to, this one is going to have a little bit more information than the scalene one. So let's extend that. So if you have a triangle like this, and you know this, and let's have A, B, and C like that. If C is given, right? If C is given, then angle A, which is also the same as angle B, right, can be found by going 180 minus angle C, all of that divided by 2. And so C is given, right? How about this? C is given, right? The non-equal, the one that isn't the same. So how about we go and put this with A and B, because that's telling you that these are congruent. And extending this column a bit. On the other hand, if you have A, B, and C like this, and these two sides are the same as well, let's say you have angle A or angle B is given. So let's say they give you either one of the ones that are equal. Then angle C is going to be 180 minus 2 times angle A. And I would box these in. Oh, undo. Be so easy, right? We could do that. And I could also say that this might be 180 minus 2b, right? Like it depends on which one they give you. But as soon as we know A, we can also right away label B because they're the same. So these two formulas I will use quite often. Okay. This is what I missed all this time, being able to look at my students and know when they're done writing down the slide. Obviously, all three sides are congruent. All three angles are congruent. All angles are actually 60. That's always a guarantee. Doesn't matter how big or how small the triangle is if they're all the same, then we know that this is 60, 60, and 60. And there's no formulas or anything like that there. And we're going to just practice the isosceles right underneath it. So just make a line like this. One that goes up a bit, an angle, and then cut back, but have a little bit of an extension at the bottom there. This angle is 115. These two sides are the same. This would be A, and this will be X. So sometimes I use a lowercase letter right in there. Sometimes when they're outside on the corners, we use capitals. And that probably I didn't review the 3-letter notation. We got to make sure we know the 3-letter notation for angles, which I'm also going to review before we start going over those questions that I assigned for homework. Okay. This is an isosceles triangle. Okay. To find this angle here, because we know that bless you, we know that this angle, because of the markings, this angle is across that one, so we know that this angle will be the same as this angle. So we know that we can split the difference in half, right? So to find angle A, we just go 180 minus 115 divided by 2. However, I will emphasize the invisible brackets, right? Every time you have something like this, you need to make sure the top is done first, and then you divide by 2. Some students just enter it all in one shot, and they get the wrong answer. So we have 65 divided by 2, which is 32.5 degrees. So this is what we were after. That's angle A. Oh, sorry, you can't see that. Off the chart. Okay, and then angle X. How would you find X? At this point, you should know this already. You see a straight line. Wiki wiki. Corresponding? I'm afraid this is the wrong territory for there's no parallel lines. Straight angle. That's what you were saying? Straight angle? Yeah, this, right? The bottom is a straight line. And you see splitting, right? So these are next to each other along the straight line. Let me highlight that for you if you can't see it. There it is. Where's Waldo, right? There it is. Hey, we should call that Where's Waldo? Find a straight line, right? And so angle X is simply 180 minus the 32.5. It's 147.5 degrees. I will say that it's straight angle, right? All right. Yeah, just because you know what saying comes to mind, just because when the hammer is the only tool you have, then everything is a nail, right? Everything in life is a nail. So just because you know your corresponding angles and all that, not every time is going to be applicable, okay? So there is that. We're going to leave it for now. Enough of triangles. One more example behind this. So have your rulers handy. You're going to need them. So we're going to make 3 parallel lines. I'm going to use every second line to guide. They're the same, about the same length. And we're going to have one cutting here and one cutting there. We are guaranteed. Let's put arrowheads at the end of all of these here. We're guaranteed that all 3 lines are parallel. That's good to know. So they're essentially a copy of a copy of a copy, right? There's the same lines being cut by 2 transversals. So this is my transversal number 1. This would be I just label that for you, like I normally don't on an example. But it's like, hey, there's 2 transversals, and they're cutting through 3 parallel lines. And then we're going to fill in a little bit of information here to start you off. So this is 127. This is 72. And now I'm just going to put in numbers. Angle 1, angle 2, angle 3, angle 4, and we'll leave it for now. Yeah. So if you had a question like this and I asked you to come up with the missing, right? I want the indicated angles. You never have to do this in order, never, okay? You can do the order that you want. You just have to let me know in which order you're doing them. So we're gonna figure that out. And sometimes you have to block off a line, okay? So let's focus on this transversal first, okay? I'm looking at these 2. I'm looking at the positioning of them. What would we call them? Alternate something. Exterior, right? But what about this one, Mr. Dirksen? It's kind of inside outside, right? Well, don't worry about it. Right now, look at those 2 angles you're referring to and just focus on their lines, right? So yes, I will figure out, I'll put a number 1 here and say that angle 4 is going to be 127 degrees. And that's because alternate exterior, what happened there? Exterior angles are congruent. That's my first one done. I'm going to actually write that in just to make sure I know what that is now. And now you can actually use that to solve. You can actually take it as part of your chain, right? Or you can just go back to the original and this one. So what is the original, the 127 and the 1, what would we call them? Corresponding, right? What about this line in the middle? Forget about it, right? It's between this and this line. Okay, so second angle that I am solving for is number 1, and it's also 127, and it's corresponding. Corresponding angles are congruent. That's the property that I'm referring to there. Could you have used a different route? Could you have used 4 and 1? What are these 2? Alternate interior, right? And it would also have given you a 127, so it doesn't matter how you do it. As long as you tell me how, that's all you need. Okay, we're done with this. You cannot travel sideways because these 2 lines are not parallel. Okay, so let's jump over to this one here and let's see what we can do. Let's try these 2. What are these 2? Alternate interior, is that what I'm hearing? I think that's what I'm hearing. I'm not just hearing what I want to hear, right? Did you do your bed? Yes. Did you brush your teeth? Yes. You really did? Yeah. Alternate interior. That's what my morning sounds like. Alternate interior angles are congruent. Should have done consecutive interior, but hey, that's just how it is. I don't have an example for that. So angle 3, last but not least. All right, let's use a different one that we haven't used yet. Maybe that's a challenge that I will put on a quiz AC. You gotta make sure all of them are different. So number 2 is 72. So what do we know about these two? Vertically opposite, always true, regardless if the other lines have been parallel or not. So 72 degrees, vertically opposite angles are also congruent. So what's up with all these congruent things, right? But that's true because they're copies, right? You're making copies of the original angle, and so that's really what it is. So I'm telling my teacher the order in which I solve them, because not all of you will do it the same way. Some of you might start on this side, then jump over to this side, and that's all okay. But please let me know, because it's a nightmare marking that if I don't see your train of thought, okay? Okay. 3-letter notation. It's one more thing. Yeah, 3-letter notation. We need to review that. Notation review. So my example is always this. I make you draw a triangle like this, and then I make you split it, and we go A, B, C, and D. Okay. And so if I told you, hey, label angle A, B, D, we're going to do that in a bit. Then we're going to go label angle A, D, B. I'll ask you to label D, B, C. Angle B, C, D. Let's just do those. Like, you could go on for a long time, but I need you to just, if you pay attention, I think you got it after this, okay? If I just show you how to do this. So read it exactly the way it's stated. So A, B, D, and follow those points. So you go A, B, D. So the angle that is created is right here. It's the middle. So this is another secret. You could read it backwards, DBA, and you'd still get the same angle. Right? And so how are we going to label this? I'm going to use my highlighters. Or some of you don't have highlighters, so I get it. So I'm just going to go X, like that. And so we're going to go ahead and label that X. And I actually am okay with you doing that. If I give you 3-letter notation, it confuses me even. It takes me a long time sometimes, like, wait. I give it a letter, and I put that letter in the diagram. It's like, no longer will you be called ABD, I call you X, right? You name that angle. And so ADB, it's right here. Let's call that Y. And DBC, DBC. So it's, if you connect those points, you formed an angle there. Let's call it Z. If you want to highlight that, go for it. Choose a color and match it, right? And then BCD, BCD, right? So you start with B, you go to C, and then D, you form the angle right there. Let's call it M. So That's my review for notation, 3-letter angle notation. Okay, that's all I'm going to do here. Why is it a problem to if you want to refer to X, you cannot say angle B, correct? Because angle B is comprised of 2 angles, so that's the problem. That's where 3-letter notation has to come in. Otherwise, you won't get it, right? It's like, well, which one, BX or BZ, right? Technically, if you call B, you're calling X plus Z, right? You're actually wanting to find both of them, so that's a whole nother story. Okay, let's go to our page. Was it 16 and 17 that I assigned? I think, yeah, we're gonna go that for more fun. You add that there, right? So I'm gonna go as far as I can on these. If you haven't done them after today, I hope you can wrap your head around it and maybe go further. And I will assign more. So I lose you usually at the end. So I'm gonna already tell you which ones. Page 12 and 13. That's your homework. Yeah. And I may or may not take from that for an AC the next day. Hint, hint. Right. I do that from time to time, especially in this chapter. It's basically a homework check. Good? Okay. Determine if segment AB is parallel to CD. Show your work. And I'm telling you what you can draw from, right? This is your checkbox. How many do you need to show to be true for lines to be parallel? Only 1 out of the 4. 1 out of the 4, then you're done. So you have to have a name for them. Do we have a name for these two? We don't. Is there a way we can kind of shuffle things around a little bit until we do? Yeah, so this is what I'm going to do here. Yeah, pencil is okay. I'm going to figure out what this is. This is 68, correct? Vertically opposite angles are congruent. Do I have a name for those two? Yeah, consecutive interior angles. Yeah. So this is what I'm going to do here. 68 degrees plus 113 is 181, right? Consecutive interior angles do not equal to 180. Would you agree with that statement? Yeah. Therefore, is it or is it not? Not parallel. AB is not parallel to CD. Done. So I have to do a little bit of work in the diagram until I found a pair that I have a name for. Could you have done this differently? Absolutely. You could have found this angle here, and then you would have concluded that alternate interior angles are not equal, right? Because this is 112. And are alternate interior angles congruent in this case? They're not. So it fails regardless. Like you could do all 4, you would come to the same conclusion every time. Does that make sense? Okay, now this one. I will have to do a little bit of work here. So I have a triangle. I'm seeing a triangle. I'm going to highlight that. That's why I covered some triangle questions, right? And let's put a letter in here. Let's call this X. The 3-letter notation would have been C, CDA, right? CDA. I will find that x is going to be equal to 180 minus 100 minus 57. And so angle x is 23 degrees. Okay. What are you doing now, Mr. Dixon? Well, my goal is to, now that I have this 23, can I find this one? Why would I want to find this one? Because it's corresponding to that one. That's my way of doing it. You might have a different way of doing that. But that's my goal, to find this. I'm going to call this y. What are these? What do these three angles add up to? 180, right? Because there is a straight line right here. So all three of them add up to 180. So I can just say angle y is 180 minus the 23 I just found, minus the 94. And I'm just going to make sure I got this. Yeah, it's 63. Oh, I like that, right? It actually makes sense. This is 63 now, and these are corresponding. So you can now conclude that corresponding angles are congruent. Therefore, AB is parallel to CD. So just show me the work, put some letters in there, whatever you need to do, and it works. Okay? So you have to use triangles, straight angles, vertically opposite. You're going to need a lot of tools to get there, right? But notice how I do this. I kind of make my point, I find some angles, I recognize the name, then I make a conclusion, right? Okay, let's do a bit more challenging. Which one would you like? Oh, we only have time for one. Which one would you like me to do on 16 and 17? If you had to pick. On 17, this one here? Yeah. You don't know? Yeah, no. Page 17. Let's try this one here. So we have that this is 76. It's an isosceles. Right? This triangle here is an isosceles triangle. Okay, would you agree with that? So how would I find A? Just justification work reasoning. I know that angle A is going to be found by going 180 minus the 76 that I have on top, divided by 2. Okay. What's that? 104 divided by 2? So that's 52, right? So now I put down 52 degrees. That's all I need for justification there, to be honest. Like you've said enough there. And then angle B is right next to A. I wonder. They're along a straight line, aren't they? Doesn't look straight, Mr. Drayson. It looks like an angle. I know, but it's still a straight line. So B is going to be 180 minus 52. And that is 118, right? $128? Yeah, that's right. Sorry. I know math. There you go. 128. I wish I could tell you I do that on purpose, but I don't. Straight angle. So you did some work and your reasoning. What about C? Corresponding to which one? Okay, got it. Okay, yeah. Okay, that one I just made up, right? That I didn't know what I was talking about. A is 52 degrees, corresponding, watch this, to, I will actually tell myself that it's corresponding to A in this case. It's just easier than to track, right? Because the 52 here corresponds to the 52 here. What are these two? Consecutive interior. So I could have done theirs. Okay, wow. I have lots of options, right? What about D? Vertically opposite. That's right. I will just say vertically opposite angles are congruent. Or you can say vertically opposite to the 76, but that's good enough. I did this in the same order that it was presented, so I'm going to go 1, 2, 3, 4. You don't have to do it in that order. Maybe you have time for one more. Oh no, the bell's going to go because the time is off. Okay, try these questions. I posted the key, right? No? Are you